Welcome to Geometry Pre-AP, greatest subject in the world. Today we're going to go over the secrets of the apothem and what it has to do with regular polygons. It's kind of what I titled this lesson. And we're going to just learn how to find the area of any kind of regular polygon at any time, just giving some basic information of the figure. All right, so we have a little vocabulary to go through first. This is a regular polygon. So if we have a regular polygon, we need to define some of these pieces. And so what we have here is we have a side to start, which is right here. We have the center of the polygon, which is right here. Okay, we have a radius, and yes, a polygon has a radius just like a circle. And then we have the central angle right here. Now the central angle is this angle created by two radius right here. So this is a central angle. And then finally we have the new word for today, which is the word apothem. An apothem is a segment from the center of a polygon to the side, and it forms a right angle. All right. This polygon also has a radius because if you pretend like there's a circle around the polygon and we connected the center with the edge of that circle, that would be a radius of a circle. So a polygon has a radius also. Remember that this other segment right here, this one in red, that's the apothem. And then we have the central angle. All right, so those are the key words that we've picked up today. So make sure you know those and describe those in a picture. All right, so if we have a regular polygon and we have that central angle formed right here in red, okay, you see the central angle, then it changes as the number of sides change. And so in order to find the measure of that central angle, we take the number 360 degrees and then we divide by n, and that gives me the measure of the central angle. Okay, and so if this first one we take 360 divided by 3, that means the central angle is 120 degrees here. So then we take 360, divide it by 5, and we get 72 degrees for this one. And so you'll want to do the other two and have the central angles for those two in your notes. Okay. So you can pause the video, start back up when you're ready to move on. All right, so now what we have is we have this picture here, and it says for every regular polygon can be broken into triangles equal to the number of sides that it has. So if we look at this figure here, just move up, we could break this into triangles. So we could have like one here, one here, one here. And so this figure can be broken into 1, 2, 3, 4, 5, 6, 7, 8 triangles, and it's an 8-sided polygon. But most of the work will occur in just one of these triangles right here. So if the picture's got a lot of sides, I don't even draw all the sides. I just draw this one triangle and do all my work in here, because inside this one triangle we have the apothem, we have the side, we have the radius. Everything we need for the figure will be right there in just one of those triangles. So you might want to draw that picture and label those informations again. All right, so here's our first example. This is a regular hexagon. It has the length of PQ is 4. And so we go in here, and this piece is 4 centimeters long. You see the process of things that we have to answer here. So one of the first things we have to answer is, what is the measure of PAQ? PAQ is your central angle. So that is 360 divided by 6, which is 60 degrees. So this is a 60-degree angle. So that means from here to here is 60 degrees. Now, since this is a regular polygon and it has a radius, remember that these radius are the same. All radius in a circle are the same, so are all radius in a regular polygon. So if that's the same, then it takes that central angle and it bisects it. So this is a 30-degree angle and this is a 30-degree angle. So PAB is 30 degrees. Now remember, since this is a central angle, we got an isosceles triangle. That piece right there in the middle, that piece that's PAB, so this is the letter B, that's at a right angle, which means this is an apothem. All right, so the radius of this problem, we got a 30, a 60, and a 90-degree triangle every time. And so if this is 4, this is 2 here and here. And so that the hypotenuse is 4 and that the radius is 2 square root of 3. All right, so we know our radius is 4 and our apothem is 2 square root of 3. So if we want to find the area, this area is equal to 1/2 perimeter times apothem. Let's do our perimeter work over here to the side. There are 6 sides and each side is 4, so that's 24 units there. And so area is equal to 1/2 24 times my apothem, which is 2 square root of 3. And therefore this answer is 24 square root of 3 centimeters squared. Every time you have a hexagon, your answer is always going to be an exact answer. You don't use any trig. It always has that special right triangle in it. So make sure you remember that. There are other figures that have special right triangles that we're going to go through here at the beginning also. So I'm going to do a few examples, and then you'll have one to do. Okay, this is a square. Yes, I know you can find the area of a square as area is equal to side squared, but you need to understand that it's a regular polygon and it works just like a regular polygon. So if we connect the P and the A and the Q, we create the central angle. So the central angle is 360 divided by 4, which is 90. So that central angle is 90 degrees. Then we put an apothem in here. I'm just going to put that as point B. And remember that the apothem takes that 90-degree angle and bisects it. So we got a 45, a 45, and a 90. So this is a 45-degree angle. And so then it told me that PQ from here to here was 10. So this is like an isosceles triangle. So this is 5 and this is 5. And in 45, 45, 90, the apothem would be 5 and this would be 5 square root of 2. So our radius is 5 square root of 2. Our apothem is 5. So if we do our perimeter work, our perimeter will be 4 times 10, which is 40. Our area is 1/2 perimeter times apothem, so that's 1/2 40 times my apothem, which is 5. And so that's 20 times 5, which is 100. And by the way, we knew this was 100, remember, because the area of a square is side squared, which is 10 squared, which is 100. So even if we change the formula, we still get the same area. You'll need to know that a 45, 45, 90 triangle, though, is inside that square. And we don't talk about the radius when we normally talk about squares, so remember that. All right, so here's another regular triangle. This is a regular triangle. It's the equilateral triangle. Yes, I know you can find the area of side squared, square root of 3 over 4, but we're going to do it at the 1/2 PA part. So remember, central angle, 360 divided by 3. This time it's 120. So that's a 120-degree angle. Remember, we put the apothem in here. Okay, and so remember that would bisect this to make this 60 and 60, and this is 30, and this is 30. All right, it told me that P to Q was 12 square root of 3. Remember, this is like an isosceles triangle, so it bisects that, so that's 6 square root of 3 here, 6 square root of 3 here. Let's go ahead and fill in the rest of the information. This is a 60-degree side, which means that the apothem will be 6 and that the radius will be 12. Okay, so remember we had a 120-degree angle here. This was a 60-degree angle. Our radius is 12. Our apothem is 6. Let me remind you that you can go back to the first one. Look where the 3069 is in here. The 30-degree angle is in a different place than on the equilateral triangle. So watch out for that. So that changes how you work your ratios a little bit. So our perimeter is 3 times 12 square root of 3, which is 36 square root of 3. So our area is 1/2 PA, 1/2. My perimeter is 36 square root of 3. My apothem was 6. We can take 1/2 of 6 and make this 3. And so then when we work this one out, we get 108 square root of 3. And of course we have yards squared since this is area. All right, so I worked through the first 3. Those are the 3 types of problems that use special right triangles. All the other regular polygons use different triangles. All right, so here's one for you to do. This is a hexagon. Work this hexagon out. Pause the video, turn the video on when you're ready to check your answer. Okay, so you should have all your work on there, and now that you're done, you can check your answer, and it should be 72 square root of 3 kilometers squared. You need to have all your other work, show your 1/2, your perimeter, your apothem, all those things in your work so that you can turn that into me or show me the following day. All right, so now this is a regular pentagon. This is where they start changing. The first 3, the square, the equilateral triangle, the hexagon, all use special right triangles. The rest of these questions do not. So what do they use? They use trig. So let's go with the process here. Let's create our central angle. That's 360 divided by 5. So that's 72. So this is 72 degrees. So from here to here is 72 degrees. We put our apothem in to create that PAB. There's a right angle there. And so it bisects, so that's 36 degrees right there. All right. Our radius was 10 in this problem. So in this problem, I need my apothem and I need the length of a side. So if I call that x, the side's going to be 2x. Remember, I have to find the perimeter of this figure eventually too, because I got to do area is equal to 1/2 PA, perimeter times apothem. So how am I going to find A? Well, that's going to be trig. So I'm going to do, that's adjacent and hypotenuse, so that's the cosine of 36 degrees equals adjacent, which is A, over the hypotenuse, which is 10. So my apothem is 10 times the cosine of 36 degrees. I got to find x there. That's going to be sine. So the sine of 36 degrees equals x over 10. So x is going to equal 10 times the sine of 36 degrees, but that's only half the side. So if I want a side S, I got to do 2x, which will be 20 sine of 36 degrees. Now my perimeter, P, is going to equal to 5 times whatever S is. So that's going to be 5 times 20 sine of 36 degrees, which I can simplify that out to be 100 sine of 36 degrees. This is my perimeter. All right, now I'm ready to get over here in my work. Area equals 1/2. My perimeter is 100 sine of 36 degrees times my apothem, which was 10 cosine of 36 degrees. Now, I can do a little simplifying here if I wanted to, but I'm actually just going to leave it like that. Now it's time for the calculator. So we take our calculator. We got 0.5 times parentheses 100 times the sine of 36, close that up, times 10 cosine of 36. Now don't forget, you had trig in here. So don't forget to check your mode. I think I left off a parentheses there at the end. So we'll make sure to put that in there. All right, and then your mode should be set to degrees. Remember that at the end of your problem. Close that parentheses, and then we hit enter. So our answer is 237.7641. We can go 4 decimal places if you'd like. So 237.7641. So this is a regular pentagon. All the other figures besides those first 3 we did use trig every time. All right, so here's what I want you to do. This is a regular polygon. Count your sides and stuff like that. Pause the video, work this problem, and then turn the video back on when you're ready to check your answer. All right, so now that you turn the video back on, you should have 101.8234. Of course, that should be feet squared. All right, don't forget to use your trig. The actual angle for this one, remember that central angle is 45 degrees, but the PAB is 22.5 degrees. You kind of did a problem like this in the last unit where we did that little octagon problem at the end of the special right triangles trig area practice. All right, so now I'm going to do one more with you, and then you're going to have one left to do. Notice here, this one I said the n is equal to 7. The side length is 10 millimeters. I'm not giving you a picture. Everything happens in that one little triangle in the problem, so I'm just going to draw that single triangle. All right, remember that the central angle is 360 divided by 7. That doesn't divide out evenly, so I'm just going to leave it as 360 over 7. But then I got to take 1/2 of that, remember, because this is an isosceles triangle and it bisects for the apothem. When I do half of that, I get 360 over 14. You know what? It's a fraction. I'm just going to leave it like that. So that's 360 over 14 as that angle. Okay, my side was 10. Remember, it's bisected, so this is 5 and this is 5. I'm going to need my apothem. Okay? I'm not going to worry about the radius, so we don't need to do the radius here. Radius doesn't help us solve for the area. We need apothem when we need perimeter. So I can do my perimeter. My perimeter is going to be 7 times the sides, so that's 70. But I need that apothem. I'm going to need trig. So that's adjacent and that's opposite. So that means I'm going to have the tangent of 360 over 14 equals opposite, which is 5 over adjacent, which is A. So remember that I can interchange the extremes here. So I get my apothem is equal to 5 divided by the tangent of 360 over 14. So over here, I can even write in apothem as 5 divided by the tangent of 360 over 14. All right. So now we got to work our problem out. We got to finish it up here. So area is equal to 1/2 PA. So area equals 1/2. My perimeter is 70. My apothem is 5 divided by the tangent of 360 over 14. Now I like to remember that there's going to be a lot of parentheses here. So if I'm going to put this into parentheses, I'm going to have one here and here also. So that I remember that when I'm putting that in the calculator. All right, so let's go to our calculator. Actually, let's go back to that problem. If I've got all this, couldn't I go back in here and just simplify this and make that 35? Wouldn't that be easier to type in? So can't hurt there. It's just a number divided into another number. Now I say, let's do the calculator. So now we have 35 times parentheses 5 divided by the tangent of 360 divided by 14. I got to close that for that angle, and I got to close that to have that 5 divided by the tangent of 640. Once I have that and I hit enter, I have my answer. So 363.3912. 363.3912. And of course, let's go, yes, millimeters squared. All right, here's one for you to do. N is equal to 9 here. Side length's 10 millimeters also. Draw your picture, show all your work. Pause the video. Turn the video on when you want to check your answer. All right, so if you turn the video back on now, the answer that you should get here is 618.1824 millimeters squared. And that should be the one where you have the work for. So there's about 3 problems you're going to have to show me the work for when you come into class. Make sure you have those. And that's regular polygons. And we will see you in class on Monday.